Good morning, folks. Welcome to Simultaneous Equations. Alrighty, we've been through normal linear equations, quadratic equations, and now it's time to go to the simultaneous equations. Okay, first of all, what we'll look at is just what a simultaneous equation possibly might look at and why it's different to linear equations and quadratic equations. What you might notice with this particular question, when it says solve the following, okay, instead of just having an x or an x squared, we now have two different variables or pronumerals, so two different letters that we're trying to find the value of. We're trying to find the value of x and the value of y, which makes it a little bit more challenging. Now, you would have come across this in junior years. Okay, in junior years, what you would have been given is an axis. Okay, an x and y axis. You would have been asked to draw the two graphs of x plus y equals 10 and x minus 2y equals 5. Now, these two graphs I'm about to draw have absolutely nothing to do with those two graphs, but I'm just showing, for example, you would draw two straight lines. Okay, that would be what you would have done in the past. And then what you would they would have asked you to have done is to locate the point at which they intersect or they cross. That would give you an x and a y coordinate, which, funny enough, is what you're trying to find the value of. So basically, when you're trying to solve simultaneous equations, you're trying to find the value of x and the value of y of where those two particular straight lines will sort of will intersect or will meet. Okay, that's basically what simultaneous equations are. So let's have a quick look at a more applied question before we get into simultaneous equations. We've got here, we walk into a corner store, we buy 2 cans of Coke, we buy a Snickers, and it equals $5. Now, the idea is we want to find the value of the can of Coke and the value of the Snickers. Now, at the moment, there could be lots or nearly endless amounts of different combinations. For example, the cans of Coke could have been $2 each, and the Snickers could have been $1. Okay, or it could have been, the cans of Coke could have been $1 each, and then the Snickers could have been $3. Lots of different options. So what we need some more information, a second part. So let's say the next day I walked in, I bought another 2 cans of Coke, but this time I bought 3 Snickers, and it cost me $8. So what we can now do, we can compare the 2 days by looking at the differences of what we bought. Now, obviously, the 2 cans of Coke, nothing changes there because I bought 2 cans of Coke on both days. But what does change is on the second day I bought 3 Snickers as opposed to the 1 Snicker. So if I find the difference of that, we get 2 Snickers. So I basically bought 2 more Snickers on the second day as I did on the first day. And if I find the difference of the cost, I would find out those 2 Snickers would have cost me $3. So if 2 Snickers cost $3, then 1 Snicker or Snickers would obviously cost half of that, which would be $1.50. Okay, we can divide it by 2 to find that answer. So I've now found the value of what 1 Snicker is. Now, how could I find the value of the can of Coke? Well, I know 2 cans plus the Snickers, which cost me $1.50, equaled at $5. So if I take away the $1.50, I should be left with how much the 2 cans cost me, which would be $3.50. And then obviously if I halve that again, that would give me what 1 can of Coke would equal, which would be $1.75. And I've now solved my problem. I know how much the can of Coke costs and I know how much Snickers cost. Because I was able to, again, you can see there, eliminate by subtraction and find the difference of what I purchased. Now, that can be written as a simultaneous equation. Let's say the Coke was X and the Snickers was Y. Let's rewrite that and say, well, the 2 cans of Coke, so 2X, plus the Y equaled $5. And the second day, the 2 cans of Coke, or 2X, this time plus 3Y equals $8. Now, I always like labeling my equations 1 and 2. We said by the method of subtraction. Okay, 2x minus 2x is 0, disappears. 3y minus y equals 2y. 8 take away 5 equals 3. Therefore, y equals, divided by 2, 1.5. And that's where my $1.50 came from. Once I've got that, we can now substitute it back into one of these two equations. 2x plus the 1.5 equals 5. take the 1.5 away, 2x equals 3.5, halve it, we get 1.75, and look, that's what we had there, $1.75. So I found my x and my y values through what we call elimination. Okay, can get a little bit confusing. We're going to look at a couple of questions now. So let's look at I guess quite a general question. X plus 2y equals 7, 5x plus 2y equals 11. Now the whole idea of elimination is eliminating one of the letters by either addition or subtraction. So let's have a look. In this question we have 2y and 2y. They're both the same. So what can I do in order to cancel them out? Can I add them or can I subtract them to make 0? Well, if I add them, that would make 4y. That wouldn't work. But if I subtract them, at equals 0, they disappear. So let's use subtraction. So we'll call this 1, this one 2. I'm going to say 2 subtract 1. So it means I'm going to start with all 2, a second equation, and I'm going to subtract the first. The reason for that, if I start with the 5x and subtract the 1x, I'm left with 4x. It's a positive number. Had I done it the other way around, I would have got x minus 5x, that would have been minus 4x, so it would have been a little bit harder. Okay, so 5x take away x is 4x, 2y take away 2y equals 0. That's the whole idea of it. 11 take away 7 equals 4. No, 3. Sorry about that. No, 4. Don't know what's going on there. Okay, so equals 4. Therefore, x is equal to, divided by 4, 1. So I have found my x value. So now let's how can I find my y value? Let's put x equals 1 back into one of these two equations. Both will work. Let's have a look at the first one. Okay, let's have a look. 1 plus 2y equals 7. Let's take the 1 across. 2y equals 6. Let's divide it by 2. Y equals 3. So I've got my solution. Let's see what happens if I put it into the second one. Okay, so 5 lots of 1 plus 2y equals 11. So 5 plus 2y equals 11. Let's take the 5 away. 2y equals 6. Divide it by 2. Y equals 3. Look, it's the same answer, so it doesn't matter which one you substitute it back into once you've found that first value. Okay, and that's pretty much about it. Now obviously there are some harder questions that will come up, so let's look at another one. This case is slightly different because if you notice, the two x's are different, the two y's are different. Okay, so we can't find something at the moment to eliminate. Let's call this 1, let's call this 2. Now we have spoken about, let's for example, we had two fractions, a half plus a quarter, for example, and we wanted to figure out how to add those two fractions. Well, obviously you have to make the bottoms the same. So I can make the bottom the same by timesing the top and bottom by the same number, which makes it 2 quarters plus 1 quarter, which now equals 3 quarters. Okay, we're allowed to do that, and that's the same sort of theory with our equations. We can change any of the equations as long as we multiply the entire equation by that one single number. So let's have a look. Let's say, for example, I wanted to turn this y into 2y. What can I times y by to make 2y? Well, hopefully you said, well, we can multiply the whole thing by 2. If I do that, I'm going to make a third equation, or timesing by 2 is the same as doubling it. 3x times 2 is 6x. Y times 2 is 2y. 10 times 2 is 20. So what you can hopefully see is I've times the whole thing by 2. So actually I haven't really changed the value of the whole equation, just the way it looks, just like we did with the half and changing it into 2 quarters. Now what we can do, by using our subtraction method, we can see we've got the 2y and the 2y are the same. So let's now say the third equation subtract the first equation. Okay, 6x take away 5x is 1x, or just x. 2y take away 2y is 0. 20 take away 18 is 2. So x equals 2. So look at that, nice substitution. Now what we can do, we can put x equals 2 and we can put it into any of these equations. It doesn't matter which equation we put it into. I'm going to chuck into the first one. Okay, and say 5 lots of 2 plus 2y equals 18. 10 plus 2y equals 18. Let's take the 10 away. 2y equals 8, so y is equal to 4. And I now have my two solutions. You could try test it if you wanted to put them back in. I mean, for example, let's try both of them, substitute back into the second one. 3 times 2 is 6. Y is 4. 6 plus 4 equals 10. Look, it works out, so it means we've done it correctly. Okay, let's have a look. We've got 2 more questions I want to look at. Okay, this is quite similar, but there's a slight difference. Okay, so let's have a look. We've got the two y's the same. We've got a y there, and we've got a plus y there, and we've got a minus y there. We need to put something in between them in order to make it 0. Either a plus or a minus. Now, we've been doing minuses of late. And let's see what happens if I did a minus. Y minus minus y. Well, that would actually create a plus, which makes 2y. It wouldn't get rid of the y's. So I'm going to add those together. Y plus minus y. Well, that's replaced with just a minus. Y minus y equals 0. So what we're actually going to do this time, we're going to add everything as opposed to subtracting. Okay, because again, if I subtracted, the y minus the minus y would not get rid of the y's. So let's add them together. And again, it doesn't matter which way, because you're adding, it doesn't matter which way you add. Okay, subtraction is slightly different. So we're going to start with 1, we're going to add 2. Okay, 2x plus 3x makes 5x. Y plus negative y is 0, cancels out. 12 plus 13 makes 25. So x is equal to 5. Now that I've found that out, let's substitute it back into the first one. 2 lots of 5 plus y equals 12. 10 plus y equals 12. Therefore, y is equal to 2. Again, we can check it. 3 times x, 3 5s are 15, minus the 2 equals the 13. That's correct, it works out. Okay, so in that case, we had to add the two equations together as opposed to subtract. And that's where this probably gets a little bit difficult sometimes. And the last question, which is probably the most challenging, we've got 2x and 3x, so they're obviously different. 3y and 4y, they're obviously different. Now, if we just quickly go back to this question here, we created a new equation by doubling that second one, if you recall, because y, double it, makes 2y. Okay, which this becomes a little bit similar. However, if I had something like this, if we did a half plus a third, well, obviously if I times 2, it won't make a 3. So what we had to do was to find a common denominator. Okay, so in that case, we would have times the bottom by 3 and the top by 3, which makes it 3 over 6. The bottom by 2 and the top by 2 makes it 2 over 6. We could then add them together to make 5 over 6. The same thing applies. We want to find a common number that we can create. And it doesn't matter which, we take the x's or the y's. For example, 2 and 3 both go into 6, as we saw here. So I could times this whole thing, this by 3, and I could times this by 2. If I did that, we're going to create 2 new equations. So let's do the first one. 2, we're going to times this whole thing by 3. 2x times 3 is 6x. 3y times 3 is 9y. 26 times 3, what's that going to be? 3 times 20 is 60, plus 3 6 are 18, so it's going to be 78. So I've times that whole lot here by 3. Likewise, I'm going to make a fourth one. I'm going to times this whole thing by 2, or doubling it. 3x times 2 is 6x, 4y times 2 is 8y, and 38 times 2 is 76. Now, you could have done the y's. You could have used 12y and times this whole thing by 4 and this whole thing by 3. Doesn't matter which one you do, as long as you make one of the letters the same. So now we've done that, we can do a process now, because these are both positives, 6x and 6x. can we add them or subtract them to make 0? We'll need to subtract them to make 0. So we're subtracting. This has got the biggest y, so we're going to do the third, take away the fourth. So 6 take away 6 is 0. They cross out. 9 take away 8 is 1. And 78 take away 76 equals 2. Look at that. We've now got y equals 2. We now have 4 different equations that we have the option of substituting back into. Let's just choose the first one because it's nice and easy. So let's substitute the y equals 2 back in. We get 2x plus 3 lots of y equals 26. Let's simplify. So take the 6 away, we get 2x equals 20. We get x equals 10. And we can double check any of these questions we're putting x and y back into. For example, let's do this one here. 6 times x is 60. 8 times 2 is 16. 60 plus 16 is 76. That works out. We could have done this one. 3x is 30. We could have said 4 times y, which is 2, is 8. 30 plus 8 equals 38. That works as well. Again, you can check them. Okay, look, this is pretty challenging stuff. I've gone through all the different types of simultaneous equations, okay, or linear simultaneous equations, so all sort of x's and y's only. Have a go at some of these questions. If you need some more help, let me know. This is supposed to be difficult, so I expect you to have troubles with it, but it doesn't mean you don't try. Okay, so good luck with it all. Again, replay this if it helps you. Even test yourself on some of the questions and see what you can do. Okay, good luck. You might need it.